Hey everyone, this is Carrie, one of the Chem 4 PAL leaders, and today I'll be doing video segment for exam number 3, practice exam D, number 15. So please pause the video and take a moment to read this problem and think about the question. Before we begin, let's start by writing out our steps. Step 1, write a chemical reaction equation. Step 2, make a flowchart with conversion factors. And step 3, solve for the mass in grams of sodium iodide. Yes, we are still working with flowcharts, even though that was from last exam. So everything in this class is cumulative. So a really cool technique that I always like to use when solving for these type of problems is highlighting keywords or key ideas. So I'm going to highlight dissolved lead-2 ions, as well as precipitate and lead-2 iodide. Key ideas and key terms that I should keep in mind when solving for this problem. So let's start with step 1. Step 1, write down a chemical reaction. So this is a chemical equation that I have written for the above problem. It's asking us how many grams of sodium iodide must be added to the solution. So the solution contains lead-2 ions. So we know that our reactants are sodium iodide and the lead-2 ions. You may be wondering, where did I get the nitrates from? So this nitrate came from our solubility rules. It will be much easier for us to work with if lead-2 had a partner. Therefore, based on our solubility rules, we chose nitrate because we know that the lead-2 ions are in aqueous form due to the keyword above, dissolved lead-2 ions. We have our balanced reaction. Let's draw a visual. Here we have the sodium and iodide ions floating around the water, which are added to the dissolved nitrate and lead-2 ions. And when these two solutions are added together, there's a formation of a precipitate at the bottom, lead-2 iodide, and we also have sodium ions as well as nitrate ions floating around in the aqueous solution. We have our balanced chemical reaction. Let's go ahead and move on to step 2. Step 2, write out a flowchart with the conversion factors. So we know that we'll be starting with grams of lead, and we'll be needing to go into moles of lead, into moles of sodium iodide, into grams of sodium iodide. And now that we have our flowchart, we definitely need our conversion factors. So this conversion factor, where did we get that from? And where do we get this conversion factor as well as that conversion factor? So let's start with the middle. This one is usually the hardest conversion factor for many people to visualize. So we can use our balanced chemical reaction to convert from moles of sodium iodide into moles of lead. And to get into grams of lead into moles of lead, we can use the periodic table to find this conversion factor because this is the molar mass of lead. And to find the grams of iodide, we need to use the moles of iodide to go into the grams of iodide. And we can use the molar mass calculation using the masses of iodide and sodium on the periodic table to calculate this number. Now we have our flowchart along with our conversion factors. Let's solve this problem. We know that we'll be starting with grams of lead, which is given above. And we know that we want to end in grams of iodide. So please pause the video and take a couple of moments to solve for the problem. This is the equation and how I set it up, so make sure my setup matches up with yours. Notice that the grams of lead cancel, as well as the moles of lead cancel, as well as the moles of sodium iodide, and we're left with grams of sodium iodide. Also, keep in mind of the significant figures. We know that the beginning 1.50 grams of lead is 3 significant figures. We know that the moles of lead going to grams of lead, that's 4 significant figures. And we know that the 2 moles into 1 mole, that's infinite number of significant figures. So we're not going to account for that in our calculation. And we know that in the sodium iodide molar mass, we have 5 significant figures. Now let's plug this information into our calculator and solve for the grams of sodium iodide. And what I got was 2.17 grams of sodium iodide. The correct answer for this problem is 2.17 grams of sodium iodide, which is letter A.